Hello everyone, this is Professor Lee again, and we are going to study another chapter today, right? And this would be this would be the last topic that we are going to study for the course. As you know, after this, then we're gonna have Q&A plus some exam sessions, right? So please read this. Let's watch this video lecture and study this chapter, right? So this is basically from chapter 6, topic 6.2, right? And uh, this PowerPoint file for this topic, this recording is also available. So you should be able to download the PDF file, the PowerPoint file from the resource section. I would recommend you to print it out, then have it next to you while you're watching this video. So you can pause and write down any comments or make note if necessary. Okay, so what we are going to study, it's called normal probability distribution. Now, normal probability distribution is one of the most important topics in statistics, right? And it describe it's one of the most important distribution for describing continuous random variable. Meaning something like this. If any distribution has continuous and random variable nature, then that distribution might be able to recognized as normal distribution. Well, let's think about these examples here. Say, for example, test score. Let's say 100 people took a same test. Then what do you expect the result of that exam? I'm expecting there will be a lot of people who did about in the medium, and there will be a couple of not that many people who did extremely well, and there's not that many people who did extremely low. So distribution itself would be normally distributed. Now let's go to page 4, and that's the general shape of the distribution. So if this distribution, this general bell shape, if this is referring to an exam score, as you can see, it's high in the middle. I guess the average is going to be right in the middle, and there's not many people who did really well and not many people who did really bad, but majority is right in the middle, right? So in that nature, the bell-shaped curve is what we call the normal distribution. Now, if you like to know the actual mathematical formula, how we get that bell-shaped curve, it's right here. Do we need to know that? Not really, not really for this course. Do I want you to see it at least once? Yes, I do want you to see it at least once, what it looks like. But you don't really need to study this extensively. I just want you to see what this normal probability density function looks like. So meaning like this, how do they graph this line? That's what I'm asking. How do they graph this line, this bell-shaped curve? They graph this line when they graph this function, basically, right? That's what it is. So let's take a look at a couple of other important characteristics of this normal distribution. The first one is it's symmetric. So meaning the left from the middle part, the left side, the right side, they are exactly the same, right? You can see that, right? From the middle part right there, the left side, right side, they are exactly the same. Now, another characteristic, Well, characteristic of what? What are we talking about now? We're talking about the characteristic of what's called the normal distribution. Sometimes they say normal probability distribution, or sometimes they just simply say normal distribution, and they are talking about the same thing, right? Okay, so if it's a normal probability distribution, then its mean is right in the middle, right? The first characteristic was symmetric, right? Page 4, right? Symmetric, right side, left side, that's exactly same. The second one is mean. It has a mean which is right in the middle, and it also has a standard deviation sigma, right? It has a standard deviation sigma. Now, if you remember the meaning of standard deviation, I mean, we know what mean is. Mean means, the usual average, the middle value. But what does standard deviation refers to? What does this refers to? This number, say standard deviation is 5. What does that mean? Well, standard deviation describes the spreadness of the data. So if the standard deviation is high, that means it's a spread out data. If standard deviation is low, then it's going to be concentrated data, right? We'll talk about that a little bit more later. Okay, so the highest point, the middle point, should be the mean and the median and the mode, right? So if a distribution is normal distribution, the middle value should be the mean, the middle value should be the median, middle value should be the mode as well. Now, mean can be any numerical value, negative, 0, or positive. Meaning, if it's exam score, and professor said, oh, this time the average score for this exam was 25, then we're talking about right here, right? The middle value was 25. If it's about, say, certain store's balance sheet for last 1 year, and they just broke even, meaning they didn't make any money, but they didn't lose any money, then the middle value should be 0. Now, if there's some other distribution that the average is a negative value, then it could look like this if the average was negative 10. So we know it's a bell shape, but the average value is going to be all different depending on what type of situation that you are in, right? Now, another characteristic that we talked about, the sigma. Sigma was what? Sigma was the standard deviation. Sigma was standard deviation referring to the spreadness of the data set. So let's compare the 15 and 25. Now, if it's a smaller standard deviation, compare these two, that means it's concentrated data. If it's concentrated data, then it should look like this. It looks like a sky blue line. Looks like this because most of the data points should be rather concentrated. So you're expecting a skinnier graph. If the standard deviation is high, then you are looking at a spread out data. So it's going to be lower and more spread out like that, right? So that's if you have a large standard deviation, it's going to be getting flatter and flatter. You'll have a wide spread of the data distribution. If standard deviation is small, then you'll have more concentrated data points. Okay, now area under this normal distribution curve must be 1, right? It says right here, must be 1. Also means the left side, the right side is going to be exactly 0.5, half and half, right? Altogether 1. So that's another characteristic of what's called normal distribution. normal distribution. Now let's talk about another basic characteristic. This is basis for empirical rule. So what does that mean? That means something like this. 68.26% of entire data value must lies within plus minus 1 standard deviation of its mean, whatever that means, right? Whatever that means. Well, it means something like this. Now let's say this is the mu, this is the mean, and if you have 1 standard deviation down and 1 standard deviation up, well, let me try with this with the note, right? Let's say you took an exam, and professor said, oh, this time our class average was 50 and our standard deviation for this exam was 5. And professor said there was like 100 people took the same exam, and the result, exam result was normally distributed. That's what the professor said. Then what can we guess? We can guess something like this. You know, if you actually have to graph the exam score, the middle value must be what? Professor said the average was 50, so middle value was 50. And standard deviation was 5. Now let's go back to the empirical rule for now. Now it says 68.28% of a normal random variable distribution lies within plus minus 1 standard deviation of its mean. Alright, so let's go back to the drawing board, the blackboard. So what does that mean? That means, you know, this is our standard deviation. So if you go 1 standard deviation up, then you'll have another interval. Say this would be 55, right? From 50 you go 5 up. If you go down 5, this would be 45, right? And according to this rule, 68.26% should lie between these two intervals. So that means this shaded area must be 68.28%. So you can say, when professor say, oh, this time average was 50 and standard deviation was 5, then you can say that 68.28% student who took that exam must get their score between 45 and 55, right? That's what this empirical rule really means. All right. So as you can see, if you go 1 standard deviation up and down, that's 68.26%. If you go 2 standard deviation up and down, then that's cover 95.44%. What does that mean? That means, you know, simply like this. If you go 2 standard deviation up, that means 1 standard deviation up is here, another 2 standard deviation. Say that must be what then? That must be 60 then. And if you go 2 standard deviation down from the 50, then must be 40. So this interval between 40 and 60, this interval covers how many percent? 95.44%. So you can say, oh, 95% student who got between 40 and 60 in that exam, right? Based on this empirical rule. And if you go 3 standard deviation up, or down, that's going to cover 99.72%, practically everything, right? Practically everything. So if you look at this slide, you can see that this is the mean. If you go one standard deviation up, one standard deviation down, that interval, whatever that interval will be, covers this much, 68.26. If you go two standard deviation up right here, two standard deviation down, that's 95.44. Three standard deviation up, down, 99.72%. Practically almost everything, right? If we know that this distribution is normally distributed, right? Then we can apply these rules. All right. Now, there is, so, let's go back to that exam question. Let's say, so you happen to get, say, 60. That was your score, right? And roughly say 95% students got anywhere between these two interval. What does that mean? That means how many percent is actually outside of this interval? Let's say roughly say this is 95%. Then how many percent should be outside? That means 5% should be outside, right? 95% is inside this interval. 5% is outside. If 5% is outside, then this portion should be 2.5%, right? And this portion should be also 2.5%, right? 2.5%. So if you happen to get 60 at that exam, that means only 2.5% student who did better than you, right? And what's the rest? If this is 2.5, the rest, which is behind you, must be 97.5%, right? 97.5% is behind you. So you're like top 2.5%, right? If you got 60 when you have this situation, right? Which is nice. Now the problem is, what if you got 57? What if you got 57? Yeah, well, 57 should be right here. Right? And let's say this is 57. And you want to know how many percent student did better than you or worse than you. Now, if it's like a one standard deviation up, like 55, or two standard deviation up, 60, or even three standard deviation up, 65, then you should be able to calculate that proportion. But what if it's like some odd number, like 57, 58, like 53, or 42, all those odd number? Then how would you be able to figure out how many percent of students who did better than you or worse than you? Well, not at the moment. Not at the moment. But that's why we are developing the same idea, but we are developing this as what's called the standard normal probability distribution. Standard normal probability distribution. Now, standard normal probability distribution is almost very similar to the previous just the usual normal probability distribution without the standard. It's very similar to that, but there's one thing that's been added, that is standard deviation. The mean is going to be 0. Mean is going to be 0. 0 for what? 0 for standard normal distribution, and standard deviation is going to be 1. So mean is going to be 0, standard deviation is going to be 1, just like that. The middle value is going to be 0, standard deviation is going to be 1, then that's standard normal probability distribution. That's what you call the standard normal probability distribution. Okay, so if, going back to that exam score question, if you happen to get, say, 55 or the 60, then you should be able to figure out the location. If not, if you get like 57 or 52, then it's very difficult to figure out. But if you can somehow convert this situation into what's called the Z situation. What's Z? Standard normal distribution. If you can convert your situation into Z situation, then you should be able to figure out exact location for every single score, not just 50, not just 60, every single score. Something like 57, 52, 59.25, any point. Why and how? Because that standard normal distribution has a table that we already know. So what I want you to do, you can probably Google up this table, the Z table, or the standard normal distribution table, or the textbook should have the table, appendix size that they have table, or you can just Google up the Z table, then you should be able to figure it out. Or I'm going to actually upload one of those tables, the Z table, in our resource section, so you should be able to download it from there too, right? Okay, so once we convert our situation into what's called the standard normal probability distribution situation, then we should be able to figure out everything. So how do we convert our situation into Z situation? Well, we use this formula, right? We use this formula. So Z equal x minus mu over sigma. This is how we convert our score into the Z score. Well, what's x? X would be, say, your exam score, right? Say 57. What's mu? It's the average. In our exam score example, that would be 50. What's sigma? That's a standard deviation, which is 5 for our example, right? Okay, so if you convert that, your x into Z score, then we can figure out everything. Well, let's try this example. Well, before we go any further, let me actually pause here and let me try a couple of other technique before we get into this technique. So let's end our first video here. Okay.